Hi everyone, welcome to Focal Academy. See this problem. Here current source was given here. This current source was connected parallel with a resistor and capacitor. So resistor is given as 10 ohms and capacitor is given as 2 farads. And asking that how can you find the average power supplied to the circuit. So where I of t current was given as sum of current signals, that is 2 plus 10 into cos of t plus 10 degrees plus 6 cos of 3t plus 35 degrees. So this is one current signal, this is another current signal, and this is the DC current signal. So totally this is one total current. Okay. Now how can you find the average power supply to the circuit? This is the problem. So here we want average power. So for calculating average power, so must and should we need current and voltage. Here we have only current is there, but there is no voltage source to the circuit. So for that, first of all, how can you find the voltage V of t? So in the first step, first of all find overall impedance. So from that we can find voltage. Means according to Ohm's law, we know that V equal to I Z. I is total current and Z is total impedance for the circuit. So from this we will get voltage for the given circuit. So for that, first of all find impedance of the circuit. So here resistor and capacitor is there. So resistor impedance is 10 ohms only, and for capacitor impedance 1 by SC. It is the impedance of a capacitor. So here C is 2 farads given here. So 1 by SC. C means 2 farad. That is 2S. So 1 by 2S is the impedance of capacitor. So 10 ohms is the impedance of resistor. So let this is Z1 and this is Z2 impedance. So here two impedances are in parallel. So whenever impedances are in parallel, the overall impedance of circuit, that is 1 by ZT equal to, so 1 by Z1 plus 1 by Z2. So from this we will get ZT equal to, so product of that impedances upon sum of the impedances. Now apply this formula. So from this we will get overall impedance of the circuit. So that is ZT equal to, Z1 is 10 ohms and Z2 is 1 by 2S upon 10 plus 1 by 2S. In the numerator 2 1s 2 5s. So that is 5 by S upon, here LCM is 2S. So 2S into 10, 20S plus 1. So here SS cancel. It becomes 5 2s are 10 by 1 plus 20S. So this is the overall impedance for the given circuit. We know that S means J omega. So write in the form of J omega form. So in the place of S substitute J omega, we will get overall impedance equal to 10 by 1 plus 20 J omega. So this is the overall impedance of the given circuit. Now we can easily find overall voltage V by producting with current I. So that is voltage V equal to, ZT is we got, this is, so 10 by 1 plus 20 J omega into current I. Now how can you find the voltage? Here current is having multiple current waveforms are there. So remember that the voltage is product of voltage and impedance. So however the current format is there, means current waveform is there, so in that same format voltage will be there. So first of all find DC signal. Next at omega is equal to 1 and omega is equal to 3, we will get some 3 different signals. So let's see here how to find it. In the given current I, here this DC signal is there. So here 2 into cos So this can be written as 2 into cos 0t. Okay, so that means omega is 0. This is omega equal to 1. Here omega equal to 3. So that is the standard signal, that is amplitude having cos of omega t, some phase signal. So by comparing with that, we'll get omega is here 0 and here 1 and here 3. Now at omega is equal to 0, we will get corresponding DC voltage, and at omega equal to 1 corresponding voltage signal, and at omega equal to 3 we will get corresponding voltage signal. So like this in the same format. So for that, here current into impedance is there. So this impedance must should convert into phasor form, because the divisions and multiplications between phasor forms are very easy. So that is voltage V equal to 10 by, so its amplitude is root of 1 square plus 20 j omega square, that is 400 omega square. So this is the amplitude, and phase angle is tan inverse of imaginary part by x part, that is 20 omega by 1, that is 20 omega into current I. Now we can easily find corresponding voltage values. So for DC we get corresponding DC voltage, for this signal the corresponding voltage signal, for this signal the corresponding voltage. So let's see here. So in this current, the DC current is 2 amperes, omega is 0. So at omega equal to 0, substitute omega value 0 in this equation. So then we get voltage, that is equal to 10 by root of 1 plus 0 square, nothing but 0. Angle is tan inverse 0 is 0 degrees into I. I is at omega equal to 0 is 2 into 2. So be careful here. So most of the students make mistake here only. So 10 by 1 plus 0 means 1, root means 1 means 1 only. So 10 by 1, 1 only. Angle is 0 degrees into 2. So we know that angle 0 by angle A equal to angle 0 minus angle A. So here 0 is there, here 0 is there, total 0, that is 10 into 20 with angle 0. So it can be simply written as 20 only, because here also angle 0. Means this signal having 0 degrees phase. Okay, so for the voltage, the D signal is 20. Now find the corresponding signal for this at omega equal to 1. Here omega is 1. So note this value here. So at omega equal to 0, we have voltage is 20. Now at omega equal to 1 radian. Now substitute omega equal to 1 in this equation only. So it becomes so V equal to IZ. So V equal to Z is 10 by root of 1 plus 400 omega square. Phase angle is tan inverse of 20 omega into current I. Now substitute omega equal to 1 in this equation, we will get voltage at omega equal to 1. So that is V equal to, so 10 by root of 1 plus, say 1 square is 1 only, so 1 plus 400 into tan inverse of, this is phase angle, so So tan inverse of 20 into 1 means 20 only. Tan inverse of 20 into current I is, now current I, how can I write it? So convert this into phasor form. So having amplitude is chan, amplitude is tan, and phase angle is 10 degrees. Phase angle is 10 degrees. So 10 into phase angle 10 degrees, that is the current at omega equal to 1. Now it becomes 10 times 100 by root of 401 into phase angle is 10 here, and below phase angle is tan inverse of 20. Now use calculator here. So by using calculator we will get, so amplitude is 5, phase angle is minus 77.14 degrees. So at omega equal to 1, the voltage V equal to amplitude is 5 and phase angle is minus 77.14 degrees. Now third signal is there, third current signal is there here. So here omega equal to 3. So for this omega equal to 3, now substitute omega value 3 here, we will get, so for omega 3 equal to V is equal to how much? So V equal to 10 by root of 1 plus 400 into omega means 3, nothing but 3 square 9. Phase angle is tan inverse of 20 into 3, that is 60 into current. So current is at omega equal to 3, how much amplitude is there here? 6 amplitude is there. So amplitude is 6 and phase angle is 35. Because here impedance also in amplitude and phasor form only. Now simplify H. So 10 by, so this value becomes 3600 plus 1, that is root of 3601. Here 10 into 6, nothing but 60. Take as directly 60 here. Phase angle is 35 here, and below tan inverse of 60 degrees. This is the phase angle. Now by using calculator we will get this value as, so 1 with the phase angle minus 54.04 degrees. So that is 1 amplitude and phase angle is minus 54.04 degrees. Now convert this information into like voltage signal. Let's see here. Now we got voltage signal V of t, that is equal to, at omega equal to 0, 20 is there, that is DC voltage, plus next signal is amplitude is 5, cos of omega is 1, that is 1t, plus phase angle is minus 77.14, that is minus 77.14 degrees. Next plus amplitude is 1, cos of omega is 3, so omega t, and phase angle is minus 54.04 degrees. So this is the required voltage for the given circuit. Now we have current and voltage is there. Now how can we find the average power? Now we can easily find average power because we have voltage. So let's see here how can we find the average power. So average power P equal to, so first of all just product the corresponding DC voltage and DC current, that is 2 into 20, plus next off of product the corresponding signals amplitude, that is 5 into 10 into cos of the difference between the phases of the current signals. So here omega is equal to 1, here also omega is equal to 1. Okay, now for the signals only the change in the phase, that is 10 minus of minus 77.14 degrees, or take or subtract from this, that is minus 77.14 minus 10, no problem, because cos is a even function. So cos of minus theta gives cos theta only, nothing change. Okay. Next, plus same format, half of the product of the amplitudes, that is 6 into 1. Next, into cos of the change in the phases, that is 35 minus or minus plus 54.04 degrees. It becomes 220 40 plus here 2 ones 2 5s, 5 phasor 25 into cos of, so minus or minus plus, that is 87.14 degrees plus here 2 ones 2 3s, so 3 into cos of, it becomes 89.04 degrees. By using calculator, it becomes 40 plus this value becomes 1.247 plus this value becomes 0.05, that's equal to 41.5 watts. So this is the required average power for the given circuit, and this is the process of simplification. And thanks for watching. Please subscribe, like, share. Thanks.